Hey, what's up? Welcome back to this new video. This one is paper 1-2 of February-March 2023 for paper A-level math, paper 1. Now, with that being said, let's move on to the questions we have for you today. Now, let's move on to question number 1. So, a line has equation this. This is my equation number 1. A curve have equation this. Equation number 2. Okay. Now, let's see what is the question we have for you. So, we have to show the line and the curve meet, intersect, for all the values of k. Okay, so basically we have to show they have a solution, because that's what it means. If they have a solution, they meet, right? Now, something we have to know right away is that to know if they have a solution, we have to test the discriminant, which is b squared minus 4ac. When this value is more than 0 or equal to 0, it means it has roots. It has real roots. It meets, so it is good, right? It meets, it has values, good to go. However, if b squared minus 4ac is less than 0, then it does not have no real roots. So that's the basic concept behind this question. We have to use that to solve this, right? Now, first thing first, obviously, we have to test if they meet or not, so we have to solve them simultaneously. So on one side you will have 3x minus 2k is equal to x squared minus kx plus 2. Okay, now send everything to one side, you will have x squared minus kx minus 3x plus 2 plus 2k. Now let's try to make this look pretty. Look in a simpler way. For example, I can factorize minus sign, that should become k plus 3x, and then plus 2k over here. Now we should know this is the value of a, value of b, of c. So therefore we have to test. Now let's of course use our formula here. B squared minus 4ac. B squared is k plus 3 square minus 4 times a times c. Now of course you might be asking about the negative sign, so when you square something it will become positive, so there's no need to write that. So expand, let's see what we have. That should become k squared plus 6k plus 9 minus 8 minus, of course here I have k missing, minus 8k. Now simplify, let's see what happens. That should be k squared minus 2k plus 1. Now, this is my value for b squared minus 4ac. Now, can you tell if this is going to be positive or negative? Well, it's not very obvious. So, whenever this happens, we tend to complete squares, right? So, here we have 1 k squared minus 2k plus 1. So, how do you complete squares? You just, again, this is 1 here, should be pretty simple. This is 1 over here, so we have x, so k here, not x, so k. Here we have minus 2, we'll write minus 2, divide by 2, square. Square this 1, plus the value in the back, and minus the same value over here. Here you go. So this is how you will complete the squares. Again, this is just one of the ways we do that. There's other ways I can show you guys as well. That should be k. 1 square is 1, so minus 1, this 1, plus 1 minus 1. So this will become k minus 1 square. Now, let's say you don't know how to use this method. We can always go back to use comparison. For example, 1k squared minus 2k plus 1 is equal to, now we wish to complete the squares, it should be k plus a squared plus b. For example, right, it should be in this form. Now we try to expand and compare the values. For example, this should become k squared plus 2ak plus a squared plus b. Now by comparison, this is 1 and 1, so good to go. This is 2a is the value of minus 2, therefore a is the value of minus 1. Last one is a squared plus b has to be the value of 1, so b is the value of 1 minus 1 is 0. So therefore this method as well, we conclude that should be k minus 1 squared plus b is 0. So this is also the complete square form of this equation right here. These two methods give you the same value. Now obviously, square of something can never be negative, so we confirm this is always going to be more than or equal to 0. Thus this confirms it will have roots. It means that it will have a solution. It means that they will meet for all values of k. So by showing that this b squared minus 4ac is more than this, we have shown that they will meet for all values of k. Okay, so this is your question number 1. Now let's move on to question number 2. So here we have a function of f of x defined by this. Alright, cool. A sequence of transformation is applied in the following order to transform f of x to g of x. Okay, so from this we are going to transform this to this by applying these 3 transformations. Now at first we have what? At first we have y is equal to x squared minus 2x plus 5. That's the first equation. Now for the first transformation, number 1, it is a stretch in the direction of the x-axis with scale factor half. Now because of the 2 here at the base, that will become y is equal to 2x squared minus 2, x become 2x plus 5. That's step number 1. Now step number 2 for this one, reflection in the y-axis. So number 2, so when you reflect in the y-axis, the value of x become negative x, so that will become minus 2x squared minus 2 minus 2x plus 5. And finally, when you stretch in the direction of the y-axis going upwards, we have to multiply the whole thing by the scale factor here, 3 times everything. So now we have to expand this one by one and see what happens. So this will be 3. That will become 4x squared plus 4x and plus 5 times 3. That should become 12x squared plus 12x plus 15. And this is your answer in this form right here for your equation of g of x. Okay, always solve one by one, as one step at a time to find the answer for your question number 2. Now let's move on to question number 3. So right now we have a curve has equation this. Alright. Now a point is moving along the curve. Okay. Now find the x value of the point on the curve at which the x and y coordinate are increasing at the same rate. Now what does that really mean, right? So this is what we want to know. For example, let's say I have a graph of, this is the y-axis and this is the x-axis, for example, right? It just means that logically, let's say x, so here we have 0, x increased by 1. So obviously because they're increasing by the same rate, y will also increase by 1. Let's say x increased by, again, by 1. This will also increase by 1. So can you see a trend here? It will increase by the same amount as x is increasing. Therefore, we have this movement in this direction. Now, what is the gradient of this direction? Pretty simple. It is a straight line, right? We use the height by the base, so 1 by 1. The gradient of this line will be the value of 1, which means if x is increasing at the same rate as y, we understand at that point dy by dx, which is the gradient, have to be the value of 1. So using this knowledge right here, we have to solve for that point. So first thing first, we have y as this, so find dy by dx to begin with. Now 1 over 60 is just a multiple, you can leave this outside. That will be 2. 3x plus 1 minus 1 become 1, and then times d by dx of this, that should be just 3. Simplify, that will be 6 over 60 times 3 plus x, 3x plus 1, sorry. That will be the value of 1 over 10, 3x plus 1. This is your dy by dx. Now, we understand it requires this to be 1, so equate that to 1. Let's see what happens. So finally, by cross multiplication, you will have 3x plus 1 is a value of 10. Therefore, 3x is a value of 9. X will be the value of 3. And this is your question number 3. We just require the x value. So x is 3 for 4 marks. Question number 3. Now let's move on to question number 4. The circumference around the trunk of a large tree is measured and found to be the value of 5.00 meters. Okay. Now after 1 year, the circumference is measured again and found to be 5.02. Okay. Part 1. Given that the circumferences at the yearly intervals form an AP, so now we know this is AP already, so we have to know which equation are we going to use. We have to find the circumference 20 years after the first measurement. So I think the main point here is to understand this. Okay, after the first measurement. So at first we had 5, and then it became 5.02. Now, the difference here is 0.02. That's the common difference. However, the question is not asking you to use 5 as your first value, but to use 5.02 as your first value. And then increase as we go for 20 years, because say after the first one, so we ignore the first one. So here, A is 5.02, and D is this value. We have to use our formula for AP. So the 20th term should be what? So we should know the nth term is given to you by this formula, which is Tn is going to be A plus n minus 1 times Z. Therefore, T of 20, that should be A, which is the first term of 5.02. N minus 1 is the value of 19 times D is 0.02. That should be 5.4. So 5.40 meters for the 20th term of your progression. Then let's move on to part B. So here we have what? Given instead the same thing, but here we have a geometric progression. So one more time, the first term here again will be the value of 5.02, because after the first measurement, so we are ignoring the value 5 again right here. But now for geometric progression, we have the common ratio. What is that? It is the first value here divided by this. So let's see what happens. That should be 5.02 divided by 5. That should be what? That'll be 1.004. Okay, so let's move on. So here we have to use the formula for the GP. We know it should be T of n term is equal to A or n minus 1. A is A, which is 5.02 here, times R, which is 1.004, and minus 1 should be 19 in this case. 5.02 times 1.001 power 19. That should be 5.41557. But correct with VSF, you will say obviously she's 5.42 meters for your answer for question part B. And that is your question number 4. But the catching point here is we have to take this one into account after first year. After first year, so we just ignore the first value here at 5, ignore this one, and look at this one as your first term to proceed. This is your question number 4. Now let's move on to question number 5. So here we have points A and B, these 2 points. So A is this, B we don't know, should be X and Y. It lies on a circle with center minus 2, 5. This is the center. Now, the line of AB has equation this. Alright, so we have to use this information to find the coordinates of B. Now, let me use, I guess, a small diagram here. Again, it is not exact. It is just an illustration to help you kind of know what are we trying to find. This is a circle here, for example. The center is here. For example, that should be minus 2 and 5. Okay. Let's say we have the point A is somewhere over here. Let's say over here. Why not? Who cares? That should be 7, 12. And the point B is somewhere over here, because why not? Right? And we have the equation of line AB. This equation has been given to you by y equal to minus 2x plus 26. That's the equation of line AB. Now what else? The center here is minus 2, 5. Okay. Now we have to find the point B. Now you can see clearly the point B lies on the circle. Therefore, you can say that the point B is a point of intersection between the circle and the line. So we have to find the equation of a circle to begin with. So how do you find the equation of a circle? We have to have the center, which is given to you. Perfect. Now we just have to know how to find this. So usually this is how it looks like. It is x minus, let's say this is A, plus y minus b equal to r squared, where A and B are the center of your circle and r is the radius of your circle. So this is the usual form of a equation of a circle. So we have to use that to, you can use it to find the equation. So x minus A is just a value of minus 2. That should be plus 2. Of course, I forgot something here, square and square, for the equation of circles. Plus y minus b, so y minus 5. That should be r squared. Now, what is the value of the radius? So pretty simple. Because we know the center, we know this value, we understand this is the radius. So we have to find the length of these. We have to find the length between these 2 points. So we can use our formula, pretty simple. That should be what? 7 minus 2 is 9. Square should be 81. 12 minus 5 is 7. Square, that should be 49. So root of 81 plus 49, that should be 130. Therefore, the radius is the value of root of 130. So r square, obviously, that should just become x plus 2 square y minus 5 square equal to 130. This is my equation number 2. Equation number 1 is right here. So again, how do you find the point B? The point B is a point of intersection between the line AB and the circle. So of course we solve simultaneously. So now we just have to plug in back in the main function. Expand, you will have the value of x squared plus 4x plus 4. Now y is the value of minus 2x plus 26 minus 5 squared is 130. Now simplify this. That will become minus 2x plus 21 squared. That should become 4x squared. That will become 2 times minus 2 times 21 should be minus 84. X and plus 21 squared is the value of 441. Now replace everything back now, so that should become, here we have x squared plus 4x plus 4 plus equal to 130. So now we have to simplify this whole equation and see what happens. So here we have 1x squared plus 4x squared is 5x squared. 4x minus, it should be 84x here. That should become minus 80x. And then we have 4 plus 441 minus 130. That should become 315 right here. Double check. So 4 plus 441 minus 130, that should be this. Now because everyone is a multiple of 5, we can divide by 5 everywhere. Let's see what happens. This will become x squared minus 80 divided by 5 should be 16, and plus 63 equal to 0. Okay, so one more time, because everyone is a multiple of 5, I decide to divide by 5 to reduce this to this, because it's simpler to work with this. Now, you can solve this by using your formula, right? Or you can factorize, that's up to you. Now x squared is the value of x times x. Now 63 is what? So we should know it is, well, I know it's 9 times 7. So I'll use this pair. 9 over here, 7 over here. Minus 16 should be minus 9 minus 7. Solve. X can be the value of 9 or X can be the value of 7. But here we have 7 already, so we don't need to look into this one. Look into this one. Replace. Y is a value of minus 2x plus 26. So replace x in here to be minus 2 times 9 plus 26. That should be the value of 8. Therefore, finally, the point B was found to be 9 and 8. And this is your answer for question 5. We first have to find the equation and then solve simultaneous equation to find the point B. Now let's move on to question number 6. So in this expansion, it is given that the coefficient of x power 4 over that of x is 3. Now use this information to find the possible values of a. So we have more than one value of a in the answer for this question. Now, so one by one, we have to first expand this. So, well, you can either expand everything, it's up to you, or you can choose which one to expand, because we only care about the term in x power 4 and the term in x power 1. So usually, how would you expand this whole thing? X over a plus a over x squared power 7. It should look something like this. So 7 combination of, let's say, n, for example. The first would be x over a times x over x squared. And because here we have n, that should be n over here, and that should be 7 minus n. Now choose values of n such that we have the correct term for this expansion. Now again, how do you do this? It's only by trial. It means that I have to test this in my mind, or you can write this down. You can test. Again, this is not magic. We test things out before we choose which one to. Then we plug in the values on the equation. So let's see. If I choose n to be what value, would I get x power 4? I can choose n to be the value of, for example, if I choose 2. If I choose 2, this will become, this is the value of a here, I apologize, a here, okay. If I choose 2, that should become x power 4, that will be 5, so it will cancel, become 1, so it will be useful. So let me do this. If n equal to the value of 2, that will be 7, choose 2, x over a, that should become 5, times, that should be a over x power 2, power 2. Now 7 choose 2 is what? 7 choose 2 is a value of 21 times x power 5 over x over a power 5 times a power 2 over x power 4. So this will cancel with this, and this will go away with this. Therefore, in the end, this whole thing will become 21 times x over a power 3, right? This is simply 21 over a power 3 x. Okay, so we need the term in x, so we have the term in x for the bottom one. Now let's try one more time. What is going to be the value of n so that we have x power 4 for our term? Test. N can be the value of, if you put 1 here, what happens? If you put 1, that will become 6, and that will become the value of 2. So yep, it will work out. 1, that should be 7, choose 1, x over a power 6, a over x squared power 1. That would be 7 times x power 6 over a power 6, a over x squared. Now this will go away. This will be 5, sorry, 4, not 5, and this will become 5. That will be 7 over a power 5. This is the value of x power 4. So this is my term in x power 4 and my term in x as we need. Now finally, we have this equation that we have to use. The coefficient of x power 4 is the value, this one. So basically, eventually we have to write 7 over this one divided by the coefficient of x, which is this one, 21 over a power 3 is the value of 3. So use that equation to find the values of a. So first thing first, we can try to cross multiply and see what happens. Or we can simplify this first. What is 7 over this one? Now divide will become multiply. Flip this upside down, that will become a power 3 over 21. That will become gone. That should become 2 here. That will be 1 and 3. That will become 1 over 3a squared. So right now we have the value of 1 over 3a squared is 3. Therefore, you would say, send this here and this here. A squared is a value of 1 over 9. So a will be the value of plus minus 1 over 3. So these are the two possible values of a for your answer here for question number 6. This is not a tough question, I would say, but again, you can always make mistakes in the expansion. Just be careful when you expand these terms. And this is your question number 6. Now let's move on to question number 7. So here we have to first, by obtaining a quadratic equation in cos theta, we have to solve this equation. So first change that into cos something. We'll see. Now tan theta is simply sine over cos. So sine times sine will be sine square over cos. Is a value of 1. So cross multiply, you will have the value of sine square theta is a value of cos. Now we also know, well, obviously this is the value of 1 minus cos square theta. Now send everything to one side, you will have cos square theta plus cos theta minus 1 equal to 0. So this is a quadratic equation. We have to solve this for the values of theta. So first value is a, b, and c. So cos theta is the value of minus b plus minus b squared, 1 minus 4 times a times c. That should be root of 5 over here, divided by 2a, which is just 2. So cos of theta could be two values. The first one is minus 1 plus root of 5 divided by 2, 0.618. Otherwise, it could be minus 1 minus root of 5 divided by 2. That should be minus 1.618. But obviously, this is not going to be good, not because it's negative, but because we know cos of any angle, theta or whatever, has to be between the values of minus 1 and 1. This one is outside the range, so it will not be good. So we will have only cos of theta equal to 0.6182 to solve. Now when cos is positive, we have to know it is in the first quadrant and in the fourth quadrant. This will be theta directly, and this will be the value of 360 minus theta. So theta will be cos inverse of 0.618. That will be 51.8, or it could be 360 minus answer should be 308.2. So we have these two possible values here for the angle theta for this equation in part A. Now let's move on. For part B, we have to show the left hand side is equal to the right hand side. Well, I guess we can just, simplify and then solve. So first thing first, what is tan? Tan is the value of sine theta over cos theta. Now sine is just sine, so let's simplify this. That should be sine theta over cos theta. Change divide to multiply, that should become 1 over sine theta. This will go away, so this will become 1 over cos theta. So this whole thing right here will become this. How about this one? So let's follow the same steps. Should be sine theta over the value of sine theta over cos theta. That should become sine. Divide become multiply, and flip this upside down. Something like this. This will go away. That should become cos theta. Now replace everything back in the same equation. So this will become 1 over cos minus cos theta. This is 1 over here, so we can combine them by this, and this, right? So times these two and cross multiply, we have a common base of cos theta. That should become 1 minus cos square theta, which is sine square theta. Therefore, we can simplify this. So sine squared is sine times sine. Cos is just cos. Therefore, you can say this will become tan theta times sine theta. This is shown as required right here for part B of question number 7. Now let's move on to question number 8. So the diagram shows the triangle ABC, so A, B, and C, alright, in which the angle B is a right angle. The length of AB is 8, so this is 8, and the length of BC is 4. Okay. Now the point D is on AB right here, and just such that AD is 5. So basically everything has been given to you on the diagram. We're just trying to explain what is on the diagram, right? Now, the sector DAC, right here, is part of a circle with center D. Fair enough, fair enough. Now, if this is a sector, so DAC, this whole thing, this is the radius, and this is also the radius. That should be 5 as well over here. Now, we have to find the perimeter of the shaded region. Now, this is simply the distance around the region, which is this and this. So how would you find that? So let's see what can we do to find that. So first thing first, we have to find, let's find the angle over here. So how can you find the angle over here? We can first find the angle over here, right? So using this right angle triangle, right? This is my opposite side, this is my A side. I can use tan. So tan on this angle, let's call this one angle D, is going to be the value of opposite side over A side. Therefore, D has to be tan inverse of this value. I'll use radians over here, so tan inverse of 4 over 3. That should be 0.927295 for the value over here. Now for this one, it is the pi, which is the whole thing, 180 minus this. So pi minus answer, that should be 2.21443. Okay, so now you have the angle. We can find this side easily, right? I mean, not really. We can find this side easily already. We can find this one actually easily. So first, let's find this length AB. How? By using the right angle triangle. This is the hypotenuse and these two sides. So we can use the Pythagoras theorem. So AC square has to be AB square plus BC square. So AC square we don't know, right? So let's write this down. AB square is 64 plus BC square is 16. So AC square is what? That should be 80. So AC should be root of 80. That'll become 8.94427191. Well, for now, right? Now, how would you find the length of arc? Of course, using your formula, which is arc length is equal to r times the angle. R is the radius, is 5. The angle is 2.2143. That should be 11.0715. So finally, the perimeter should be what? This length plus this one. So answer plus 8.9442719. That should be 20.01577. Therefore, correct to 3SF should be 20.0. This is your perimeter for the shaded region. That is part A of your question. Of course, show all this here in this space right here for your marks, right? Let's move on to part B. We have to find the area of this region. Now again, how do you find this? It is solved by observation. So nothing is, magic. We have to observe and then derive the values. So how would you find this area? So we can first find the area of everything, and minus the area of this triangle. Area of everything is, it is just using your formula, which is what? Area of sector is half r square, which is 5 square, and the angle is 2.2143. This is the area of the whole thing. Half times 25 times 2.2143. That should be 27.67875. That's the area of this sector over here. Now, we don't need the area of a triangle, so remove this one. How do you find area of a triangle? It is again using your formula, which is half r square, which is 5 square, times sine of the angle in between them for that. 43. So half times 25 times sine of 2.2143. That should be 9.9999. So 27.67875 minus answer. So the area will be 17.7 centimeters square for 3SF. And this is your answer for question number 8. Now let's move on to question number 9. So here we have a function f defined by this equation right here. For the values of x less than equal to minus 1. Part 1, states should be pretty easy. The range of f. Now obviously this is an easy question. However, I would like to explain what are we actually looking for. So the range is actually the y value. The y is the up and down value, right? So usually we have to sketch the graph, have an idea exactly what is the range. So let me just do that so you guys exactly know what are we looking for. So by observation, this one is a quadratic function. This should be a maximum curve because the coefficient of x squared is negative. So let's find the maximum point. So differentiate f, you will have the value of minus 6x. Now equate that to 0 to find the stationary point. So you will say, well, x will become the value of 0, obviously. Now find y. Y should be minus 3 times 0 is 0. That should be 2. So y is 2. So the max point will be 0, 2. So that's the max point. Now from the shape of the graph, we can kind of deduce what will be the shape, right? So it is a maximum curve. This is the x-axis, this is the y-axis, this is 0, 2. This is the maximum point. So you will have a shape like this. Right. That's the first part. Now, according to the question, there's a limitation here. X can only be less than equal to minus 1. So we cannot take the whole graph as, as into consideration. We have to limit this to x equal to minus 1. Therefore, let's find out what is the value of y or f when x is the value of minus 1. That should be minus 3. That will become 1 plus 2. That will be minus 1. So basically, when the value of x is minus 1, the value of y is also minus 1. So what does that mean? It means that the graph is only defined for which part? So this whole thing will become just something like that, right? So this is my graph. However, it is only defined for, this is not here, not here, not here, only from this part going down. From the value of minus 1 here and minus 1 over here, it is only defined starting from that point. So now from this on, what is the range of the graph? Range is the up and down value. As you can see, the value will always be less than this value over here. This value is a value of minus 1. So you can just write the range will be y less than equal to minus 1. Or you can write f less than equal to minus 1. This is your answer for part A of your question. Now for part B, we have to find f inverse of f of x. Okay, so let's find this. So first step, we have to let y be f of x, which is minus 3x squared plus 2. And so now we have to make x become subject. So send this over here, you will have 3. X squared is 2 minus y. Therefore, x squared is a value of 2 minus y over 3. So finally, x is a value of plus minus root of 2 minus y over 3. So finally, f inverse, it is in terms of x, so we have to write plus minus 2 minus x over 3. Now, which one is going to be the value that we are looking for? Is it going to be the plus sign or the minus sign? So for this, we have to understand that the range of f inverse is equal to the domain of f. So we know the domain of f has been given to you right here, right? This is the domain. Domain is x values, has been given to you right here. And therefore we understand f inverse can also only take value which is negative. So this is the domain. Given this is the domain, now since you know the domain is this, so which one are you going to take? So obviously you understand that when you apply square root of a value, at least in this real values, this can only be positive. Now for this whole thing to become negative, we need this to be minus sign. So therefore, we conclude f inverse of x have to be minus root of 2 minus x over 3. So this is your value for f inverse of x. Now let's move on to question part C. So we have g of x is this, for again x less than equal to minus 1. Now what is the value of f of x? Let me write this down again. So f of x was given to you in part 1 as minus 3x squared plus 2. So first thing first, we have to solve this equation. So let's find this and find this. What is f of g of x? It will be minus 3. Replace x by g of x squared plus 2. Minus 3, g of x is the value of minus x squared minus 1 squared. Now I can try to factorize the value of minus 1 outside. That will be x squared plus 1. I have to apply square as well because it is inside the bracket, plus 2. That will become minus 3 times. That should become x power 4 plus 2x power 2 plus 1 plus 2. That should become minus 3x power 4 minus 6x power 2 minus 3 plus 2. So finally, if you were to simplify again, it should be minus 3x power 4 minus 6x power 2 and minus 1. That's the first value. Now how about the rest? We can find this one now. So what is g of f of x? It is simply g is this one, so minus f of x square minus 1. Basically replacing the value of x by the value inside, which is f of x in the equation. Now simplify, let's see what happens. So here we have minus sign. F of x is the value of minus 3x squared plus 2 minus 1. That will become 9x power 4 minus, that should be 4, so 2 times 3 times 2 is 12, right? X squared plus 4. Now simplify, should be minus 9x power 4 plus 12x power 2 minus 4 minus 1. That will be minus 9x power 4 plus 12x power 2 minus 5. Again, be careful with those expansion. It's pretty simple, easy to make mistake for the signs and stuff. Now finally, plug everything back in your main equation. So here you have this, which is this, minus this whole thing. So apply minus sign in front. You will have minus 3x power 4 minus 6x power 2 minus 1. Now minus this whole thing will become plus 9x power 4 minus 12x power 2 plus 5. Then plus 8 equal to 0. Now solve. So minus 3 plus 9 will be 6x power 4. Minus 6 minus 12 is minus 18x power 2. Now finally we have minus 1 plus 5 plus 8. So minus 1 plus 5 plus 8, that should be the value of 12. So plus 12 is a value of 0. Now by observation, you can see every one is a multiple of 6, so divide by 6 everywhere. Now why do I do this? Is to simplify the equation. You will have x power 4 minus 3x power 2 plus 2. Now this one is clearly a quadratic equation. How do I know this? So if you just play around with this, for example, if I tell you let the value of, well, let me use u is x squared. So you will have u squared minus 3u plus 2. So you can see clearly this is a simple quadratic equation. You can solve by factorization, or you can use your formula to solve these two equations, up to you. 2 is 2 times 1, minus 3 is minus 2 minus 1. So you use the value of 2 and use the value of 1, but of course we don't care about u here, we have to find the values of x. So u is x squared is 2, x squared is 1. Therefore x is a value of plus minus root 2, x is a value of plus minus root of 1, which is plus minus of 1. Now you have these four values, we have to choose which one is going to be okay. So by definition, I mean in this question at least, the values of x have to be -1, at least, I mean below this, as well as this one. So confirm, we have to look into this. So after considering the limits, we understand that x can only be the negative values. X could be the value of minus root 2 and minus 1. So these are the two values that satisfy this equation, in this question at least, and this is your question number 9. Now let's move on to question number 10. So at this point on the curve, the gradient of the curve is this. Okay, the gradient is just dy by dx is equal to this. Okay, now we have the equation for dy by dx already given to you by the question right here. So use that to find the value of k is minus 2. So simple. So we have this, we know the value is this, so minus 3 over 2 is equal to x power minus half plus k. Now we know this happens at the point of 4 minus 1, x and y, so the value of x will be the value of 4. Right, replace and see what happens. That should be minus 3 over 2. What is x? 4 power minus half is the value of half. Therefore, finally, k has to be minus 3 over 2 minus 1 over 2 should be minus 2. So k is the value of minus 2. This is part A of your question. Now let's move on to part B of your question. So find the equation of the curve. The equation of the curve is basically finding y from using dy by dx. So we should know y is integration of dy by dx. So that's the main point of this question. We just have to know how to find y, which is the equation of the curve. So replace, y will be integration of x power minus half minus 2 dx. Now this will become x power half, right? Add 1, then divide by the power minus 2x plus c. Simplify, y will become the value of 2 root of x minus 2x plus c. Now we have to find the value of c. How? By using the passing point given to you by x equal to 4 and y equal to minus 1. Now will become minus 1 is the value of 2, root of 4 is 2, minus, that should be 2 times 4 plus c. Minus 1 equal to 4 minus 8 plus c, minus 1 equal to the value of minus 4 plus c. Therefore, c is the value of 3. Right, let's double check one more time. This is my equation here. Replace back in here, you'll have 2 root of 4 is 2. 2 times 4 is 8. Fair enough. And then the rest will be just the values we have. So finally, we confirm the equation of curve y equal to 2 root of x minus 2x plus 3. This is my equation of the curve. Part B of your question. So now we have to find the coordinates of the stationary point. So we should know at stationary point what happens. dy by dx have to be 0. So that's mainly the thing we have to know to solve the question. So again, the equation has been given to you already. So dy by dx is what? It is x power minus half minus 2, equate that to 0. Now we should know this is simply 1 over x power half is root of x equal to 2. Now we can just cross multiply. You will have root of x is the value of 1 over 2. Then square both sides, x will be the value of 1 over 4. Now we also have to find the y value, so replace back in the equation in part B. Y will be 2 root of x minus 2 times 1 over 4 plus 3. That should be 2, that should be 1 over 2, right? and minus 1 over 2 plus 3. That will go away. So you have 1 minus half plus 3. Should be 3.5 as a value for the y coordinate. So finally, the point is actually 1 over 4 and 3.5. Or you can write 7 over 2 as well, not a big deal, for your point. Now for part D, we have to find the nature of this point. So whenever you have to find the nature, we have to find the second derivative, which is d2y by dx2. That's the concept behind this. So we know already that dy by dx has been given to you by what? By x power minus 2, minus half actually, minus 2. So we have to differentiate one more time. So let's do this. d2y by dx2. First multiply by the power should be minus half. Then power minus 1 should be minus 3 over 2. And this will become just 0 because it's a constant, so we don't care about this. So finally, you will have minus 1 over 2x 3 over 2. This is d2y by dx2. Now, obviously, we have to test at the value of your stationary point. So at the point, we know x is the value of 1 over 4. So what is that value? Replace, you will have d2y by dx2. That should be minus 1 over 2, 1 over 4, 3 over 2. Minus 1 over 2, that should be what? 1 over 4 power, this is 1.5, that should be 0.125. So minus 1 divided by 2 times 0.125. That will be the value of minus 4 for the value of d2y by dx2. Now, we don't care about the value, we care about the sign. The sign is negative, so we confirm the point will be a maximum point because it's negative. Okay, and this is your answer for question number 10. Let's move on to question number 11. This is the last question on this paper. So here we have the diagram shows a curve x equal to y squared plus 1 right here. The points A and B are given to you as well, and we have to first find the equation of line AB. So to find the equation of a line, we first have to find its gradient. So that should be equal to y2 minus y1. So minus 1 minus 3 is minus 3. x2 minus x1 should be also minus 3, which is 2 minus 5 is minus 3. Therefore, the gradient is the value of 1. Now, once you have the gradient, we have to use a passing point. I will use this one to find the equation. This is the x value and the y value. So you use this method if you want to. X, so we have y first, minus 1 should be plus 1 over x minus 2 is equal to your gradient. So we just have to cross multiply to find the equation of the line. That will be y plus 1 is equal to x minus 2. Therefore, y is equal to the value of x minus 3. Now, because here we have x in terms of y, let me also make x become subject here. So x is the value of y plus 3. This is my equation of the straight line here, and this is the curve right here. That is part A of your question. Now for part B, we have to find the volume of revolution. So again, whenever you have to find volume, you have to know the formula we use for that. Now we have the rotation is about the y-axis, so we have to know when it's about the y-axis, the formula is volume pi times integration of x squared respect to dy. Okay, so now whenever it's about the x-axis, we have to write y squared here and dx, but here we have y-axis, so we have to write x squared inside. Now, understand this by observation. What is the volume of this region? So we first, again, so we can think of this as area to begin with. So usually we have to look at the limits first, the value here and the value here. This is the point 2 minus 1, this is minus 1. This is the point 5,2, this is the point 2. So these are the limits of your integration. Now, how would you find this area usually? You would first find the area of this whole thing, right? And then minus area below the curve. So same concept here. How would you find the volume? You will find the volume of the line when we have this revolution, and then minus the volume below formed, which is below the curve by this revolution. So we have two steps here, right? Step number 1, finding the volume for just the line. That should be limits of 2 minus 1. Here we have x, we have to find x squared. That will be y squared plus 6y plus 9. Okay, so that will become integration of y squared plus 6y plus 9 respect to dy. Now simplify, that should become pi is pi. That'll be y cubed over the value of 3 plus 6y squared over 2 plus 9y, limits of 2 minus 1. Now I can just simplify and replace. That should be pi is pi. That'll become 8 over 3. That should become 3 plus 3 times 4 plus 9 times 2. Then minus, the rest will be minus 1 over 3 plus 3 minus 9. Right? Now simplify. 8 over 3 plus 12 plus 18 minus 1 over 3 plus 3 minus 9. That should become 39 as your volume. So volume of this one will be 39 pi. Okay, to begin with. Now we have to also find the volume for the other one, which is below the curve, to remove that one, right? So that should be number 2. The equation of the curve is this, so we have to find x squared. So x squared will be y power 4 plus 2 y power 2 plus 1. So let's find this. Volume will be integration, pi here obviously, limits of 2 minus 1. Then we have the equation will be y power 4 plus 2 y squared plus 1. Respect to dy obviously. Simplify, that will become y power 5 over 5 plus 2 y power 3 over 3 plus y. That should be limits of 2 minus 1, and pi is just pi outside. Okay, this is the volume right here. Now simplify, this is pi, and the rest should be 32 over 5. That should be 2 over 3 times the value of 8 plus 2. Then everything minus, that should become minus 1 over 5, minus 2 over 3, and minus 1. So 32 over 5 plus 16 over 3 plus 2 minus 1 over 5 minus 2 over 3 minus 1. That should be 15. 3 over 5 pi for the volume below the curve that is generated. So finally, to find the actual volume for your answer should be take number 1 minus number 2, so 39 pi minus 15, 3 over 5 pi. Let's see what happens. So answer is this, so 39 minus this should be 23, 2 over 5 pi units cube for the volume.